t-tests. So I've got those T for two. T-tests are all about comparing two groups. It's going to be, both groups are going to have the same outcome or dependent variable. That dependent variable needs to be data. You should all remember what data is. If not, go back and review that video. I also, you're going to have an independent variable or some kind of comparison groups. So t-tests is good for when we're asking what are there differences? Is one thing better than the other thing? That's a kind of a t-test question. And so you're going to have those comparison groups, which are going to be levels or treatments or groups or conditions of your independent variable. Your independent variable is going to be categorical or nominal data. And with t-tests, as well as any test we learn this semester, you need that normal distribution or that bell curve. So t-tests, your book talks about single sample t-tests, which we're not going to review in 231. And then related dependent paired t-tests, all those are the same name for the same thing, and then independent t-tests. All right, so let's get into our two t-tests we're going to focus most on is related dependent or paired t-test. That is part of a within subjects design or a repeated measures design. And so when you're trying to decide, should I run a t-test, it is based on having outcome data as data, having some sort of comparison or groupings. That's going to be your independent variable. And then you have to ask yourself your study design. If it is the case where it's the same people being tested multiple times, and the multiple times is only two for T for two, it's going to be the case where I get a cup of tea and then I'm going to have another cup of tea, or you get a cup of tea and you're going to have another cup of tea. So again, same participants being tested twice. That is the within subjects T. We can also, or within subjects design for a related dependent pair T, we can also call it repeated measures. Independent t-test is chapter 8. This is a case where I get a cup of tea and you get a cup of tea. So each cup is for different people. So you're going to have two different groups. Each person can only be in one of those conditions. So we call that independent measures design or a between subjects design, and that's chapter 8. So we are first going to review some basics. No matter what t-test you run, you would be conducting hypothesis testing. Your hypothesis testing can be non-directional or directional. So non-directional is the two-tailed test. Directional is the one-tailed test. In Jamovi, we select, do we want a one-tail? And we're going to say, are we expecting decreases or are we expecting increases? Or you're going to do a non-directional two-tail test. So you choose in Jamovi. I'm going to show you that. Jamovi also gives us the exact p-value for a calculated t. So you can kind of skip over, and it will give you your degrees of freedom that you would have used, but you're going to skip over making that critical value and making those comparisons because your output's going to tell you all that. We're going to see that. Some other things that are important to know with T, Z tests and Z scores kind of had static critical values. That is no longer the case. Your critical value is going to be dependent on degrees of freedom, which is connected to sample size. And there's going to be two different degrees of freedom calculations for the two different types of t-tests. You will learn about that. But just know, in general, larger sample size give us smaller critical values. Smaller critical values make it easier to find significance or reject the null. Both of these mean the same thing. And it's also going to give us more power. So we're going to start with a paired related dependent t. Again, 2 cups of tea just for me. Same sample tested 2 times. Again, t-test only. You can only have 2 times going on there. Oftentimes when we use a related paired dependent t-test, we are interested in looking at an individual being tested over time. The degrees of freedom for a paired dependent or related t-test is n-1. So your number of people. I'm going to have 20 people. I'm going to test them twice. My degrees of freedom would be 20 minus 1. The comparisons that we would be doing, you see the verbiage of pre-test, post-test, before, after. We're getting a baseline, and then we're introducing an experiment, an intervention, a drug, and then we measure them again. Same people being measured twice is your dependent paired or related t-test. So think about questions you might have where you could think of things that you would want to to look at for that. Again, you're going to make sure your outcome variable is data. So data is kind of things you can count. And then you're going to think about, well, what would I do if I was measuring a person twice? What would that involve? Is there going to be some sort of drug or a manipulation, an experiment, or some sort of intervention? This is kind of sharing you how you look at output, and then I'm going to run some output really quickly for you. So in this data set, this is, I'm looking at number of mutual friends that I have with people I'm on Facebook with. Pre-COVID, how many mutual friends did I have with someone? Post-COVID, how many friends did I have with someone? With the general idea now that we're more socially distanced, you might connect with more people in more of these virtual ways. And so again, this is made up data loosely based on my my friend Facebook data, where I've got pre and post. So same person, I would have collected how many mutual friends we had back in, February, and then now looking at now, how many friends do we have? So then I ran I picked 30 individuals randomly from my Facebook data set. Again, I made up the post data. Then you're looking at, so that T29 refers to the degrees of freedom, and you see that in your Jamovi output there. The T is 3.27. That is what you're getting there. Your P is 0.003. That's highly significant. So that's that P value. That's exact P value for my calculated T. And then my D is Cohen's D, which talks about effect size testing, which is very important. Is 0.596, which is medium effect. And then if you're interested in confidence interval calculations, it is right there. And again, if you do not have 0 in your confidence interval, that is an indicator that you have significant bindings, which we do when we don't have the 0. If I were to calculate this T by hand, if I would have calculated, this is the top of my T formula. This is the bottom of my T formula, the estimated standard error of those differences, mean differences with different scores. And then it gives me the means here. And then it gives me estimated standard deviation and then estimated standard error. Standard deviation, again, I have some variance going on there. And means, I've got pre and post. Again, doesn't look too different, but it ends up turning out to be significantly different. Okay, so let's move into Jamovi now. And I'm going to be using that data set that I already had posted for you guys. So I had posted hours of sleep, so people had gotten an intervention on knowing about the importance of sleep. This is the made up data, and you can see that, scoot this over a little bit more so you can see that. So you've got your data in Jamovi. I went ahead and ran it into Jamovi. In Jamovi, you would go to t-tests. Make this, move it a little bit more, and then you're going to go to that paired t-test from there. And then you put hours 1 and 2. Again, this is totally optional because your homework, you're just going to do your output, but you'd put in your hours here, and then you'd keep it as students. And sorry to be moving things around on you, but this is where you select your hypotheses. Again, I would want confidence intervals, I would want effect size, I would want descriptives. I could also do the normality. All right, so then you would see you've got output, and so this is what your output looks like. So again, it's comparing, oops, I'm gonna go here. I ran it 2 different ways. I can show you those. Depending on how you ran it, depending on if you put hours 2 or hours 1 will give you if it's a positive or negative T. Again, it's the same statistic here, right? If I put in hours 1 and hours 2, it gave me a positive T. If I put in hours 2 minus hours 1, I got a negative T. Actually, it's hours 1 minus hours 2. Again, you would just know that and have to interpret that appropriately, which one was being measured first. All right, so this is students first had an average of, I had 10 students in each group. And again, those 10 students are those same students. If for some reason, if someone forgot to report hours of sleep, I couldn't have them in my data set. So I need both reports for an individual to be included in the analyses. So before the intervention, they were sleeping an average of 9.3 hours with a standard deviation of 1.3. That's not too bad for a standard deviation. I'd say that's, let's say moderate, moderate variance. And then after the intervention, I guess this doesn't make a sense. They're now sleeping less for this made-up example. And so maybe they're more stressed. Maybe I should have done pre and post-COVID with you guys all moving online instead of a sleep intervention to know the importance of sleep. Okay, so then 6.3 was the average, and again 1.06 was the variance. That could be moderate variance, moderate dispersion. When I compare the two, I see a T is 8.22, a degrees of freedom is 9. Again, 10 minus 1 is 9. I can see it's significant, and then I can see my confidence intervals. Again, anytime you don't have 0 in the confidence intervals, that's awesome. And then Cohen's D of 2.6, that's huge. Okay, so now that was your quick run of paired or related or dependent T. Those are all going to have for your homework. That's what you're going to be doing. Independent T, I get a cup, you get a cup, 2 different samples. One thing you're going to have to be concerned about when you have 2 different samples is equality of variance. You're also going to have a different degrees of freedom. It's going to be n minus 1 for your your sample 1, and then n minus 1 for your sample 2, or the total number of people minus 2, and they don't have to be equal sample sizes. When we look for equality of variance, we're going to do the Levine's test in Jamovi. And so let's go ahead and move into Jamovi for your independent t-test. Again, independent t-test, dependent t-test, both of these, you're welcome to pause the video. I know I'm going kind of quickly because I'm trying to get my 15-minute mark for this video. And so I had 2 different conditions going on. You can see this is set up a different way than the paired. This is called a long file. When we did the paired t-test, it was a wide file. You have one condition, one column is your IV, one column is your DV. So it's different setup for different design in Jamovi. So I've got 2 different groups. These are my outcome. Right, then I run the T again, going the same way, analysis, but now I'm going to go to T and I'm going to go independent T. And then I can see this is my T statistic, this is my degrees of freedom. My degrees of freedom is taken from doing, I could do 8 plus 9 minus 2, so that's 17 minus 2, which is that 15, all right, or 8 minus 1 minus 9 minus 1. My P is highly significant. Again, my confidence intervals, if I want to include that. Cohen's D is large. Anything bigger than 1 is large. Right? I can also look to make sure that I'm not violating any assumption of variance. And in this case, I am. In this example, this is not good data. Right? This is showing there's too much variation going on between these 2 groups. Right? That 0.97 and 1.77 is not good. So this I would be cautious of in running a t-test for the independent T. Okay, so that's in a whirlwind Jamovi.